Hello everyone. In this video, I'll be introducing you to binary search. So, binary search is a searching technique or algorithm that is commonly used or seen, especially in coding interviews. There are two types of search. One is linear search, or sometimes known as simple search. The other is binary search, which is what we will be going over today. Now, let's get into details on how binary search works. Let's start off with an example. Let's say that you're trying to find the word optimistic in the dictionary, which starts off with the letter O. If you know your ABCs, then you would know that it starts somewhere in the middle of the alphabet. It will make more sense to flip to the middle of the dictionary first, then see if the letter section that you're currently at is before or after O, rather than flipping section by section from start until you find O, which is a lot of work. The action of starting from the middle and then keep on searching from there is the basic structure of binary search. Important note, keep in mind that binary search can only take a list of sorted numbers or characters rather than an arbitrary list. Now, let's see another example to further illustrate this concept. Let's say that I am thinking of a number between 1 and 100. You have to guess my number in the fewest tries possible. With every guess, I will tell you whether your guess is too low or too high, or correct. The wrong way to go about guessing my number will be like this. Is it 1? Is it 2? Is it 3? All the way until you guess the number, which is using the linear search or simple search method. Maybe you got lucky and the number was 1. But imagine if my number was 99. Then it will take you 99 tries to guess it. There is a smarter approach to this problem, which is using binary search. Let's start off with 50, which is half of 100, and I would tell you that it's too low. But now you just eliminated all the numbers before 50. Next, 75. That is too high. But again, you cut down half of the remaining numbers, so the possible solution is between 50 and 75. With binary search, you guess the middle number and eliminate half the remaining numbers every time. Alright, so our next guess is 63, which is halfway between 50 and 75. And you guessed the number. And guess what? This only took us 3 attempts rather than 63 attempts if we did linear search. In general, for any list of n, binary search will take log base 2n steps to run in the worst case scenario, whereas linear search will take n steps. As you can see, binary search is generally faster and more efficient than linear search. You will learn more about time complexity and big O notation in my future videos. But for now, just keep in mind that binary search is more efficient in most cases than linear search. Now, let's see how to code binary search in Python. Keep in mind that it is more important to understand how algorithms work rather than knowing how to code it, because you can always find the source code for these common algorithms online. It is more important to understand where and how to use these algorithms. Now let's get back into binary search. The binary search function takes a sorted list and an item. If the item is in the list, the function will return its position. You will have to keep track of what part of the list you have to search through. So let's do that. We set our variable low at the beginning of the list at first and the variable high at the end of the list. Note that you have to subtract 1 from the length of the list for calculating the index of the last element in the list, because in Python, lists start off with 0 rather than 1. Now, each time you have to check the middle element. The variable mid is the middle index and the variable guess is the value at that current index. Note that mid is rounded down if low plus high is odd. Now, if the guess is too low, then we have to update accordingly. If guess is less than item, low is equal to mid plus 1. And if it's too high, we have to update accordingly as well. If guess is greater than item, then high is equal to mid minus 1. Now, here's the full code. In the code, we have low and high to keep track of which part of the list you will search. We use a while loop to run the code as long as low is less than or equal to high, because if low is greater than high, that means the item is not found in the list. Mid checks the middle element. Now, if the item is found, then simply return mid, which means that the middle element was the actual number or item. If the guess is too high, then adjust high to mid minus 1. If the guess is too low, then adjust low to mid plus 1. Otherwise, we return none, which is when low is greater than high, which means the item is not found in the list. Now, let's run our program and see what we get. As you can see, we found the item in the list using binary search, which is really fast and efficient. I hope you found this video helpful, and I definitely recommend doing a lot of practice on binary search to further strengthen the stuff that you have just learned, and also perhaps watch other videos to further strengthen your knowledge on binary search. If you found this video helpful, please leave a like and subscribe. See you guys next time. Bye.